Hello everyone. I am K. Narsimurthy, working as an assistant professor in the Government First Aid Women's College, Tumkur. Today I am going to present the video for the course B.Sc and the subject is physics. And the paper I am discussing today is semiconductor devices, digital electronics, lasers and fiber optics. In that paper, I am going to discuss the topic fundamental products, minterms and maxterm. This paper is for the final B.Sc 5th sem students. Today we are going to acquire a knowledge about the fundamental product, and also we are going to familiar with the definitions of minterm and the maxterm. How to write the minterm and maxterm, how to write a canonical SOP form, and also how to write the canonical POS form. Alright, firstly we start with the fundamental products. There are four possible ways to AND, means AND in a sense it's a logical multiplication. There are four ways to make a logical multiplication of two input signals, means two variables A and B, that are in complemented and uncomplemented form. Okay, so complemented means it is A bar. Uncomplemented or a normal form means A. It is as such we are writing A, that is uncomplemented form. Complement in a sense you have to write A bar. There are four possible ways to do a logical multiplication of two input variables, either in a normal form or in a complemented form. I have given you the example of this. What are the four different combinations? In the first combination we can write it as AB. Okay, so A dot B, I am ANDing this, means I am doing the logical multiplication. Both are in a normal form. AB bar, one is complemented, B is complemented, another is A bar B, here A is complemented, and the last one is A bar B bar. Both the variables, both the inputs are in the complemented form. These are the four ways we can represent the product of two input variables. Of course, if we come across the three input variables, there are many possible ways of representing the product terms. Now, how many ways of representing these three input variables? There are totally 8 ways to represent the three input variables in a complemented form or an uncomplemented form. These are the product terms. So the resulting product term is called fundamental products. I'll repeat this. There are 8 ways to AND in a sense logical multiplication. There are 8 ways to AND three input variables and their complements. The resulting product is called the fundamental product. Okay, what's the resulting products? How many possible ways we can do the product of three variables? So these are the many examples I have given. These are the 8 possible ways. A bar, B bar, C bar all are complemented, and A bar, B bar, C 2 are complemented. A, B, C bar 1 is complemented. A bar, B, C and A, B bar, C bar, A, B, C bar, of course the A, B, C. So these are the product terms, and we are doing AND for the three input variables, and the resulting product is called the fundamental product. So here is a truth table for the two inputs. Here is a table of writing the fundamental products, not the truth table. It's a table to write the fundamental products. A is 0, B is 0, and the fundamental product will be A bar dot B bar. How we have written this? A is 0. If the input is 0, write the variable in a complemented form. Okay, the A is 0 here, so I have written A bar. B is 0 here, again write it in a complemented form, B bar here. Okay, right, we'll go to the second combination, 0 and 1. A is 0, write A in a complemented form. B is 1, write the B as it is, normal form, uncomplemented form. Third combination, A is 1, write A as it is, normal form. B is 0, write B in a complemented form. But in the last combination, both are 1, Both are 1 means you need not complement any variable here. Write the variable as such. Write this A and B as it is. A, B. That is how we write the fundamental products. If the variable is 0, write it in a complemented form. If the variable is 1, write the variable in normal form as such. You can write the variable as such. That is how the fundamental products can be written if the two inputs variables are given. Of course, we can write it for three inputs variable also. Sum of the product. Sum of the product form is a form of expression in the Boolean algebra in which product terms of inputs are being summed together. You know what is product term is. Product term means it's a fundamental product. These fundamental products are summed together. If you sum it together, you will get SOP form, SOP equation. So sum of the product, first do the product of the variables and then do the summing. Okay, I'll repeat this statement. Sum of the product form is a form of the expression in the Boolean algebra in which different product terms are being summed together. So one thing we have to note here is it is not an arithmetical summing or an arithmetical product, but it's a Boolean logical AND. Multiplication means it's a Boolean logical and sum means it's a Boolean logical OR. It's a logical multiplication and a logical addition. We have to be very careful here. I have given you the example of this. AB is one product term, fundamental product term. A B bar is one more fundamental product term. A bar B is one more fundamental product term. All these product terms are summed together, are added together to give an expression, and this expression is called sum of the product. This is sum of the product. First we do the product and then we do the summing. First we do the ANDing and then we do the ORing. We'll move on to the next thing, which is minterm. Minterm here is the product term. Product in a Boolean function. So as I told you, the SOP is a Boolean function. SOP is a Boolean expression. In that Boolean expression, one term, one product term is called minterm. So minterm is a product in a Boolean function. Product in a sense, it's a logical AND, in which every element present in either normal form or complemented form. As I told you, normal form is writing the variable as it is. Complemented form is A bar, or you can write it as B bar or C bar. Here you can define the minterm in another way also. Each individual term in standard SOP form. We already understood what is SOP form is. Each individual term, each product term in the SOP equation or an SOP expression is called minterm. Minterm is basically a product term, or you can say each individual term in the SOP form is called minterm. Now it's a challenge for us to write a minterm for the three variables. So we are given a table of three variables and the fourth column is the minterm. I will teach you how to write the minterm for the different variables. As I told you, if variable is 0, if A is 0, write A bar. If B is 0, write B bar. If C is 0, write C bar. So if the variable is 1, you need not complement it, you write it as it is. Write it in a normal form. I'll take the second combination 0, 0, 1. A 0, B 0. A, B both are complemented. So look at the minterm A bar, B bar and C. It is not C bar, it is C because here it is 1. C is 1. If it is 1, write it as it is. Write the C, don't write C bar. Third combination 0, 1, 0. 0 means it becomes A bar. B means B is 1. So write B as it is. And again 0 in the C, write C bar. If 0, write the complement form. If it is 1, write it in a normal form. So 1, A is 1. So write A as it is. B, C are 0, write B bar, C bar. Exactly for this 1, 0, 1, write this A, B bar, C. For this combination A, B, C bar. For last combination, it is ABC. That is how we can write a minterm if the input variables are given. Right. This is canonical SOP form. So how to write an SOP equation in a Boolean algebra? That is called canonical form. So it's writing an equation in the Boolean function is nothing but the canonical SOP form. Now I'll explain you how to write an SOP equation in the Boolean algebra. The first step here is each output 1 in the truth table and write down the fundamental product for each output 1 in the truth table. Okay, so if output is 1 in the truth table, for that combination of input, write the minterm, write the fundamental term. And after writing the fundamental term, are the fundamental terms, or in a sense add, logical addition, do the logical addition of all the fundamental terms or minterms. Okay, right here I have solved this problem. Here is the table which is given for us. Okay, so three inputs A, B and C, and here is an output C out. Okay, now the first step which I have followed is identifying the output ones in this table, in this truth table. I have identified 4 ones in the output of the truth table. This fourth column is the output. So I have got 4 ones in the truth table. After finding the ones in the truth table, output ones in the truth table, write down the minterm. Write down the minterm for that corresponding inputs. Okay, so here is the example. So here it is 1 here. The combination of input for which output is 1 is 0, 0, 1. For this 0, 0, 1, I have to write the minterm. It's A bar, B bar, C. Because A is 0, B is 0 and C is 1. If I write a minterm for this combination, it will be A bar, B bar, C. So second identified output 1 is for this combination 0, 1, 0. For this, if I write a minterm, it is A bar, B, C, C bar. And the third combination for which the output is 1 is 0, 1, 1. That is A bar, B, C. And the last combination for which output is 1 is 1, 0, 1. I can write it as A, B bar, C. So now I have written all the fundamental product term or a minterm for the output 1. For the output 1. Now after that, are the fundamental products, means add the fundamental products. So I have got the 4 fundamental products. I have got the 4 minterm. Now the second step is to add the 4 fundamental products or add the 4 minterms. If I add these 4 minterms, I will get an expression y is equal to A bar, B bar, C, A bar, B, C bar, and A bar, B, C, and A, B bar, C. And this expression is the canonical SOP equation or canonical SOP form. Okay, move on to the next thing. It's a product of sum. Product of sum. Earlier we did sum of the product. Here it is POS, product of sum. It's a form of expression in the Boolean algebra where product of different sum terms of the inputs are taken. First do the summing, first add the terms and then do the logical multiplication. Okay, exactly opposite to that of SOP. Okay, so here the first term is A plus B and the second term is A plus B bar, third term is A bar plus B. All these 3 terms are product of all these different sum terms are taken. So these are the sum terms. I have done the product logical multiplication of these 3 terms. You will get a POS expression. You will get a POS form. Okay, right. So move on to the definition of max term. Max term is a sum term. Min term is a product term which is individual term in the SOP form. Here the max term is a sum term in the Boolean function in which every element present either in a normal form or a complemented form. Okay, so you can define it in another way. That means max term is an each term in the standard POS form. We understood what is POS form is. Each term in the POS form will makes the max term. So max term is an each term in the standard POS form. how to write a maxterm. How to write a maxterm for the three inputs. Again, I have given the rules here. If A is 0, write it as it is. If A is 1, complement it. But exactly opposite to how we wrote the minterm. So writing the maxterm is exactly opposite to writing the minterm. There in writing the minterm, for 1 we are writing in a normal form, and for 0 we are complementing it. But here for 0 we are writing the variable as it is in a normal form. For 1 we are complementing the variables, exactly opposite to how we did in the minterm. So this is the combination 0 0 0, all are 0. If zeros, write it as it is. Write it as it is. So A plus B plus C. Be careful, it is sum, not the product. This max term is a sum term. A plus B plus C. Look at the second combination 0 0 1. So A plus B plus C bar. I have complemented C. It's because C is 1. You're writing the max term. If the variable is 1, complement it. 0 1 0. Here B is 1. So B has to be complemented. A B bar plus C. 1 0 1. Here A has to be complemented. A bar B C. A bar plus B plus C. So 1 0 1. A bar plus B plus C bar. If 1 1 0, it's A bar plus B bar plus C. 1 1 1. So it has to be A bar plus B bar plus C bar. So one thing we have to write in writing the maxterm is, if variable is 0, write it in a normal form. If variable is 1, you have to write it in a complemented form. That has to be taken care of here. And a canonical POS form. As I told you, it's an equation. So it's an equation. I will tell you how to write an POS equation here. So there are 2-3 rules here. So first rule is, locate each output 0 in the truth table. Be careful, not the one. Not the one how we did in the SOP equation. It's a POS equation. Here you have to identify the output zeros in the truth table and write down the max term for the corresponding 0 output. And after writing the max term, so do the product of all the max term and all the max terms together. And means it's a logical multiplication. Okay, and all the max terms together, you will get the POS equation. Okay, I have given you the example. This is the 3 inputs variable, and I have given the output also. The fourth column is an output column. First procedure, first thing is to identify zeros in the truth table. You can expect 4 zeros here. 1 2 3 4 zeros. Identify zeros in the output of the truth table. After identifying zeros, for that 0 you write a max term. For that combination of input, write a max term. Here the 0 is for the combination 0 0 0. For this, if you write a max term, A plus B plus C. If input variable is 0, write it in normal form, A. Okay, so A plus B plus C. Another 0 is for 1 0 0. For that, if I write a max term, it will be A bar plus B plus C. Another output 0 will be for the combination 1 1 0. For that, you write A bar plus B bar plus C. It is not seen here in the slide. It's okay. Now for the another combination for which output 0 is 1 1 1. Okay. For this 1 1 1, you have to write all this in a complemented form. It's A bar plus B bar plus C bar. Okay. That's not seen in the slide. Okay. So I have got a 4 max term for the 4 different 0 outputs, for 4 different combinations which makes the output 0. Okay, so after writing the max term, the last step is to multiply, is to do the ANDing of all the max term. So do the logical multiplication. Here I have did all the multiplication here. The fourth term, all the 4 terms are multiplied together. So I have got an equation, I have got an expression. This expression is called POS equation, product of sum equation. Okay, so yeah, This is all about the today's video, and we have discussed the SOP means product term, and also we understood the minterm, and also we understood how to write a minterm for the three variables inputs. And also after that we also learned how to write an SOP equation for the different outputs. After that we come to the POS form, means and we understood the max term here, what how to write a max term, and also we have understood, we learned how to write a POS equation. So overall video is about writing an SOP equation and also the POS equation. We learned writing both POS and also SOP equation from this video. So these are the references which I have referred. So Principles of Electronics, Fundamental Principles of Electronics by Vasudev Ghosh, and also the Tumakuru University faculties have written a Fundamentals of Physics book for this syllabus, and also a very good old book of Digital Electronics and Multi Applications by Malvino and Leach, and a College Physics by Sundarajan. And I have searched for many internet sources also, which I have mentioned here. I hope you understand my video very well. Thank you very much.